Okay, real quickly, we're going to go ahead and talk a little bit about the week to come. First thing, number one, hopefully you have found your social security number because we need to, by Friday, the end of Friday, we need to register for this class, Math 136, through Ivy Tech. And so we need to do that. I will put in Google Classroom how to do that if you want to do that at home. I would plan to do that over the weekend, and I forgot. To bring that paper home with me, so I did not have it. So I have 6th period prep, so it'll probably go in around 6th period in Google Classroom for everybody. So if you want to do it at home, and then through the week on Tuesday, Wednesday, Thursday, I will probably just keep putting something in Google Classroom as a reminder to do this at home, to do this at home. Remember, you will get 6 hours of college credit, 1 first semester and 3 hours first semester, 3 hours second semester, if you qualify, which basically means you have to have a certain score for the SAT, ACT, PSAT, and or you'll take the asset test, which they'll give later in the month of September to all of us during a coach class if you do not meet in one of those categories. The next thing, I'm going to kind of run down what the week is, and you're not going to really like this, but I just apologize. It's going to be the way it is. But we're going to finish the notes today on 1-6. Tomorrow, we're going to work on 1-6, ask any questions on that. I felt like if I just tried to push the quiz tomorrow, that would be a little bit too much because I'm afraid you might have some questions because I went back and I looked at the assignment. And I do feel like I need to adjust it a little bit. And then we will review on the block day and take the quiz, 1-5 and 1-6 on the block day, and then review on Friday. And that means we'll have a test on Monday. I know testing on Monday is not the best case scenario, but that's what we have to do. Because I just feel like I just am not going to rush it. It's the first benchmark of the school year, and I would rather know that you're well prepared and ready to go into it, and then leave it on your shoulders to kind of look over it Sunday night. So hopefully that's what we'll do. So really this will be the last time we have to meet in a whole group setting. So the rest of the week we'll just go into our classrooms. If you do have questions on stuff, you're welcome just to bop over because we'll kind of basically be doing the same thing, but there won't be as many kids in one group. And so that way you can kind of work on your own pace. And if you have questions, you're welcome to walk over, and ask questions and get those questions answered. And then I'll probably come in on Friday to go over the quiz. I'll probably come over Friday at some point in time for Miss Elser's class and go over the quiz with you and pass those back. And then we'll test on Monday. I can tell you when you take that test, please don't think you're going to get it back anytime too soon. It'll probably be a week from Monday when you get it, because I'm probably going to need a weekend in there to help get graded. So if you would, let's go ahead and turn to lesson 1.6, the very last slide. We had just a little bit left to go, and I need to finish that. Here is the question. Here's what we had. So that's where I want you to go. If you need a 1.6, oh, Lord. There's one. Do you need one?
I'm supposed to take the test today.
The quiz?
Yeah.
Okay, drink Sental or what?
Oh, yeah, study on that.
Yeah.
Okay, I was confused.
Okay, good. That's good. Yeah.
I was really worried.
No, you're good. All right. So what I'm going to do is I have the parent graphs, and I don't have them with me, so I'm going to go back and I'm going to look at a few things. I'm going to draw some stuff in here just to make sure that you look. When we talked about verifying, we have an x cubed. And we know that graph does this, right? This is y equals x cubed. Maybe that's y equals x cubed, correct? And then we also have a graph, y equals the cube root of x. And so when we look at those two parent graphs, and again, if we were in our rooms, we would see those graphs there hanging on the wall. But anyway, those are inverses of each other. When you switch x and y and you solve for one or the other, you're going to get a cube root. If you have a cube root and then you switch x and y and solve, you're going to get an x cubed equation. So they are indeed inverses of each other. And so the part that we kind of need to be concerned about is what happens to this guy. If you have a quadratic, that's what a quadratic looks like. There's your y equals x squared. And then you would think that, hey, when you switch an xy, you should get a square root, which you do. But again, we have to kind of make a very, very point about this, a good point about this. That didn't make any sense. But anyway, So we have to make a good point at this. This is not going to be an inverse, because if I truly did the inverse, it's going to look like this. But you got to remember what we do. We switch x and y, and I told you that was like the most important thing to do. But then when you're going to look at this, you're going to have to say, oh, well, what's the domain of this? The domain of this is all real numbers, correct? And then the range, however, is 0 to infinity. Well, again, you're switching x and y. So when you switch x and y, then you have to switch the domain and range, because that's what you have. That's what they're called. And so when you look at this, I agree. The range comes here, which will now be the domain, which is going to be that, hey, you're only going to use from 0 to infinity. But when you look at the range of this guy, what's the range on this guy? Which is supposed to become the domain over here. And so what's the range on this one? Well, it also, the y values are from what? 0 to infinity. So in order for those to be inverses of each other, you can't use the entire quadratic. You can only use part of it. This guy kind of sort of wins out. So if you want to make a inverse with a quadratic, then you're actually going to have a fixed domain. You're going to have to clarify the domain. And so basically, if we want to look at this, if I only use this part of the graph, then there I have the inverse. These two would be inverses of each other, and this would be y equals x squared, where x has got to be greater than or equal to 0, or 0 to infinity. Why does it have to be that way? Well, because that's the range of this guy. And again, they have to switch. So that leads us back to this example, number 6 on the paper that we left off at. So if we look at this very last example, we found the inverse, correct? We found it, and this is it. It's x squared plus 3 over 2 equals y, or if you wanted to split that up and divide each term by 2, you could get 1/2 x squared plus 3 halves equal y. But the problem is, that's an entire parabola. That's an entire quadratic. I only need half of that. So where do you go to get half of that? Well, it goes to this guy. When you have 2x minus 3, and you have a square root, remember that expression underneath that square root has to be greater than or equal to 0 in order for you to be able to take the square root. If not, you're going to get a negative and you can't do it unless you go into the imaginary, and we're staying in the real world. So we're going to have to come over here and say, okay, well, the domain is 2x minus 3 has got to be greater than or equal to 0. And so we solve this thing out. X is greater than or equal to 3 halves. So again, keeping it in that interval notation, it would look like this. So you got 2x minus 3 is greater than or equal to 0. So x would have to be greater than or equal to 3 halves. So the domain is 3 halves or greater. But the catch is not so much the domain. That will be your output for your quadratic. It will be the output for this guy, 3 halves or higher. But my question is, what's the range? Well, again, right here, when you tell me what that expression has to come out to be, it's what the outcome has to be. That's your range. So on a square root, it's pretty easy to figure out what your range is, because whenever you sit there and say, oh, this expression has to be greater than or equal to 0, remember, this is f of x. This is how you get the y. And so you're telling me the y has to be greater than or equal to 0. That greater than or equal to is your range. When you do that, that's telling you what the outcome has to be. And so you have to say, oh, well, y has got to be greater than or equal to 0. And again, with interval notation, you could have the bracket 0 to infinity. So now you have to clarify this. This is an entire quadratic. It's going to give me an entire u, but it can't give me the entire u if I have to have a fixed domain. And that's going to be what? I'm going to have to come down here and say where the domain, or x, is greater than or equal to what? 0. So I have to put that disclaimer on there. I have to fix that. I have to give that implied domain. If I try to use all of it, I get a u, and then therefore the square root and the quadratic will not be inverses, because a quadratic as is fails the horizontal line test. And so to make the inverse a function, you can only use part of it. And I can say 90% of the time it's going to be x is greater than or equal to 0 is the disclaimer. Okay, that's typically what we'll always follow with the x squared, because that's what always the range is on a square root. Does that make sense? Okay, so with that said, here you go. So it says find the inverse of the function g of x was equal to x squared, where x is greater than or equal to 0. So again, they have this fixed domain. Why? Because when you switch x and y, what are you going to get? You're going to have to take the what? Square root of both sides. And when you do the square rooting, what are you supposed to be putting in there every single time? Plus or minus. Well, to make this inverse a function, you won't use plus or minus the square root of x. Because if you do, you're going to get this shape. We don't want that shape. That's not a function. That fails the vertical line test. And so we don't want all of it. We just want which one? The positive. And so y will just equal the square root of x. And so then you can change that to your interval notation, and it's going to give you a square root of x. Or not interval notation, to inverse notation. Sorry, to inverse notation. So you're going to get inverse notation is the square root of x, where x is greater than or equal to what? 0. Again, it will always have a fixed domain because it's a square root. Does that make sense? And so to make the square root of this thing, it's got to be greater than or equal to 0. Okay. After thinking about this and looking at the homework, that's where I felt like, okay, I need to change this up just a tad bit. So to make sure that everybody's good on that. So questions on that? Everybody okay? Okay. And I think that kind of tells us how to do everything. The number one thing, 3 ways to show or verify subjects are inverses of each other. Really, truly, the only thing I really care about is algebraically. Make sure you can do that. Make sure you can plug the inverse into the function and the function into the inverse and show that you get x. The other thing that's really important to recognize graphically, it's really kind of nice to be able to put it in a graphing calculator, and it's nice to know, yes, if I draw on the line y equals x, it's going to have symmetry. I can fold along that line and it be good. And if you make a table, here's your x, here's your y1, here's your y2, what's going to happen? If I have 1, 2, then what will I have over here? I'll have a 2, and then I'll have a what right here for the inverse? A 1. Make sense? Remember that? That's what that table is showing you. That, hey, they're always going to be just switching. Questions on that? Okay. So the assignment is here. And we're going to look at that and see what you got. So we're going to let you try that the rest of the period. Good? Okay.